The 1990s were exciting times for technology. The Hubble Space Telescope began taking jaw-dropping images of the cosmos. People were going online to the brand new World Wide Web, and the deployment of Nextgen radars gave forecasters a big picture of weather all across the United States. That same network of radar, also known as WSR-88D, still stands strong today. Keeping the radars running while collecting high-quality data is crucial, especially during severe weather. However, as radar components age, the chances of failure become more likely. When significant parts go bad, it can cause the radar to be down for several weeks. Not to worry though, a plan is in place.
The mission of the Radar Operations Center is to manage the life of the Nextgen weather radar network, and we are investing in a service life extension program to keep the radar functional till 2030 or beyond.
The overhaul involves replacing and refurbishing major components on all 159 radars. The most significant piece is the pedestal. It rotates the entire antenna, and it weighs close to 15,000 pounds. So this is no easy chore. Bottom line, the Service Life Extension Program will reduce unexpected failures and keep the radars running at peak performance for years to come.
When severe weather is about to strike, we all want up-to-the-minute information. But the radar network called Nextgen that meteorologists depend on has its limits. The biggest drawback? The equipment is typically spaced 100, even 200 miles apart.
You have a radar here and the beam goes out. But as it gets further and further away from the radar, you can see that there's this gap here because the Earth curves away from the beam. And a lot of tornadoes actually happen in that gap. And that's one of the reasons why the false alarm rate for tornadoes is almost 75% right now. The orange color is like 90-mile-an-hour winds. And then
With support from the National Science Foundation, Brenda Phillips co-directs CASA, the Center for Collaborative Adaptive Sensing of the Atmosphere. Engineers and scientists have developed and implemented a new generation of smaller, highly capable radar systems designed to be spaced much closer together. The improvement is easy to see.
So right here, this is the CASA data, and you can see basically it's this image right here is the tornado that's happening. And when you see the picture here in Nextgen, you know that the tornado is happening, but you really just can't tell precisely where it's occurring.
From tornadoes to flash floods, the cities of Dallas and Fort Worth face more than their fair share of dangerous weather. So when the CASA team was looking for an urban area to test its system at the neighborhood level, the Metroplex was a good fit.
When we have events, we try to turn those around and produce case studies where we can try to learn from what the CASA data showed us.
With smartphone technology and GPS, we can give you the information where you are now so that you can make the right decisions to protect yourselves and as well as your family members.
More accurate, localized forecasts can save businesses money as well as protect lives.
Having the data, having an emergency manager or forecaster start to analyze it and see the benefits of it and translate that into something that could be life-saving, I think that's the real excitement.
Smaller, smarter radars able to track dangerous weather street to street. That's the kind of early warning system I want protecting me, CASA. For Science Nation, I'm Miles O'Brien.